Section 3.5 is about slope-intercept form. To start this section, I'm going to build up into what slope-intercept form is with this first example. So it says, given the equation using the steps below, y equals 1/2 x minus 2. The first box says find the x and y intercepts, then graph them, labeling each. To find an x-intercept and a y-intercept, let's first look at the graph. An x-intercept is the place where a graph intersects the x-axis. All along the x-axis, we have ordered pairs like 3, 0, 4, 0, negative 2, 0, 5, 0, so on and so forth. Every point along the x-axis has a y value of 0. So if I'm trying to find the place where a line will intersect the x-axis, I would substitute 0 in for y, since I know any point on the x-axis has a y value of 0. So to find the x-intercept, I'm going to substitute 0 in for the y value. I'm abbreviating x-intercept as just x-int. So I'll take my equation, y equals 1/2 x minus 2, and substitute a 0 in for y. To solve for x, I would first add 2 to both sides. So I'd end up with 2 equals 1/2 x. And then I would divide by 1/2. Dividing by 1/2 is the same thing as multiplying by 2, so I'd end up with x equals 4. Now remember, I substituted 0 in for y, so my ordered pair would be 4, 0. To find the y-intercept, let's look at the y-axis. The y-intercept is the place where a line intersects the y-axis. If we look at the ordered pairs all along the y-axis, it'd be things like 0, 2, 0, 4, 0, negative 5, so on and so forth. This time, any point along the y-axis has a x value of 0. So to find the y-intercept, I would put 0 in for x and then solve for y. So taking my equation again, I would have y equals 1/2 times 0 minus 2. 1/2 times 0 is 0, leaving me with just y equals negative 2. Now remember, I put 0 in for x, so my ordered pair would be 0, negative 2. The problem also said to graph them, labeling each. So now I have these two ordered pairs, 4, 0, and 0, negative 2. So taking them to my graph, I would go to 4, 0. 4, 0 would be starting at the origin. I would count over to the right 1, 2, 3, 4 points. So there's my point 4, 0, the x-intercept, and then starting at the origin for the y-intercept, this time I would just count down 2 units since the x value was 0 and the y value was negative 2. And there's my y-intercept, 0, negative 2. We know that you only need 2 points to draw a line, and finding the x-intercept and finding the y-intercept actually allows me to find 2 points, which in this case are the 4, 0 and the 0, negative 2. Since 2 points determine a line, I can actually graph this equation y equals 1/2 x minus 2 by, again, just finding the x-intercept, finding the y-intercept, plotting those 2 points, and connecting them with a line. So you can see here that's exactly what I did. I had my 2 points for the x-intercept and the y-intercept. 2 points determine a line, so I drew a nice straight line through them both. And there I have the graph of y equals 1/2 x minus 2 using the x and y intercepts. The next question asked, just by looking at the equation, what intercept can be identified and where is it located in the equation? So when we look at our x-intercept, it was 4, 0. The y-intercept was 0, negative 2. Looking at this equation, I see a negative 2, the minus 2 part of the equation. So therefore, I can identify the y-intercept by just looking at the equation. So to answer this, the y-intercept can be identified, and to answer the question, where is it located in the equation, notice that the equation, the y is by itself. Whenever the y is by itself, the number that's not in front of the variable x is the y-intercept. When y is by itself, the number not in front of x is the y-intercept, which we would call the constant term. So again, looking at the equation, y equals 1/2 x minus 2. The minus 2 we would call the constant term because it does not have a variable with it. The constant term is the y-intercept of the graph of this equation. The last part says find the slope between the intercepts. we have 2 points, 4, 0, and 0, negative 2. Remember, we can find the slope by doing y2 minus y1 over x2 minus x1. So let's start with this point first. So let's start with this y value. So if I start with 0 in the numerator, 0 minus the other y coordinate was negative 2. So 0 minus negative 2. Since I started with the 0 of this ordered pair, I'm going to start with the 4 in the denominator for the subtraction of the x's. So 4 minus the other x coordinate was 0. So 4 minus 0. To simplify, 0 plus positive 2 is 2, and 4 minus 0 is 4. In lowest terms, that would be 1/2. Just by looking at the equation, where is the slope located? So looking back at the equation, we have y equals 1/2 x minus 2. We've already identified that the minus 2, or the negative 2, is the y-intercept. The 1/2 was the coefficient, the number in front of x, which ended up being our slope. So to answer this question, when y is by itself, again, y has to be by itself, the number in front of x, which again we call the coefficient of x, is the slope. That entire first slide leads us into slope-intercept form. Slope-intercept form is this: y equals mx plus b. I'm sure you've heard this before in other classes, y equals mx plus b. Again, let's take note that y has to be by itself. The m always represents slope, and the b, in this case, represents the y-intercept. I'm not entirely sure why they use a b to represent y-intercept, just kind of like how I don't understand why they use an m for slope, but b in this case represents the y-intercept. So again, y equals mx plus b is slope-intercept form. It is called slope-intercept form because when y is by itself, the number in front of x is the slope, and the constant term is the y-intercept. So again, slope-intercept form, we're given the slope and the intercept. Let's take a few notes about what slope-intercept form and how it has to look. Step 1 would be y must be by itself. The note here would be, what if y isn't by itself? If y isn't by itself, then you need to solve for y and get it by itself. The number in front of x is the slope, and the number by itself, so otherwise known as the constant term, is the y-intercept. So one more time just to go over this, slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. Y must always be by itself. If it isn't by itself, solve for it and get it by itself. The number in front of x, so the coefficient of x, is the slope, the m, and the number by itself, otherwise known as the constant term, is the y-intercept. Next, let's talk about how to graph a line in slope-intercept form. Just to reiterate, slope-intercept form is y equals mx plus b. The number in front of x, the coefficient of x, is the slope, and the constant term, the number without the variable, is the y-intercept. Step 1 would be to get y by itself if it already isn't by itself in the equation that you're given. Next, you would plot the y-intercept first on the y-axis. You have to have a place to start from, so the place we're going to start from is the y-intercept, and then we will use the slope to plot the other points. So step 3, starting from the y-intercept, the point that you plotted in the second step, use the slope, as in rise over run, to plot the other points. Now remember, you only need 2 points to determine a line. So once you plot the y-intercept, you really only need to find one other point with the slope in order to connect those 2 points and graph the line. Let's try all this out. Example number 1, fill out the rule of 4 table given the equation x plus 4y equals 8. So the rule of 4 table first wants us to state the equation. So x plus 4y equals 8. Next, we'll say it verbally. Check out how I'll write this. The sum of x and 4y is 8. You could have also just literally said x plus 4y is equal to 8, or anything more difficult or more easy than just stating it the way I did. Next, we're asked to express the equation numerically by finding the slope and the y-intercept. Our equation is x plus 4y equals 8. I can only find the slope and the y-intercept when y is by itself. Therefore, I need to take this equation and solve for y. First, let's just write the equation. We have x plus 4y equals 8. First thing I would do is subtract x. 8 minus x is just 8 minus x. I prefer for the x to go first, so I'm going to put negative x plus 8. The 8 was positive and the x was negative. Remember, there's an implied negative 1 in front of that x. So when I divide by 4, I would end up with y equals negative 1 divided by 4 is negative 1/4, and then I would have the x. And then 8 divided by 4 is 2. Do you remember when we were doing this last chapter? This is exactly why. So now that we have our equation where y is by itself, we now know the coefficient of x, the number in front of x, is the slope, and the constant term, the number without the variable, is the y-intercept. So to complete this, we would say negative 1/4 for the m and 2 for b. Next, we are supposed to express this equation, x plus 4y equals 8, graphically. We can do this by taking the information that we found in the numerical part. We know that the slope is negative 1/4 and the y-intercept is 2. Remember from the last slide, we plot the y-intercept first on the y-axis. So again, if our y-intercept is 2, I'm going to start at the origin and I'm going to count up 1, 2 units for my y-intercept of 2 and plot a point. So there's my y-intercept up 2 units. Next, starting from that point, I'm going to use my slope, negative 1/4, as my rise over run in order to find and plot the other points. So my slope is negative 1/4. So that means I'm going to go down 1 and to the right 4. Since it's negative 1 over positive 4, only one of the numbers is negative, not both. If both numbers were negative, I would have negative 1 divided by negative 4, which would be positive 1/4. So again, only make one of the numbers negative, not both, if your slope is negative. So I'm going to go down 1, since it was negative 1, and to the right 4, since my 4 is positive. So again, starting from my y-intercept of 2, I'm going to go down 1 and to the right 4 to find and plot the other points. So starting from the 2, I'm going down 1 unit and over 1, 2, 3, 4 units to the right. So there's my other point. Again, I went down 1 unit from my y-intercept and counted to the right 1, 2, 3, 4 units to the right to find my other point. 2 points determine a line. I could continue this trend. I could just keep counting down 1 and to the right 4 to find the other points, but I really only need 2 to graph the line. So once I have those 2 points, all I got to do is connect it with a nice straight line. And there you have it. There is our line for x plus 4y equals 8 using the slope of negative 1/4 and 2. Example number 2, graph both lines shown on the same graph at the right. Let's start with part A. So we have y equals 2x minus 4. The y is already by itself. Since y is by itself, I know that the number in front of x, so the coefficient of x, is the slope, and the constant term is the y-intercept. So writing it down, the slope would be 2, and the y-intercept is negative 4. Typically, you need to express the slope as a fraction, since when we go to graph it, we need to use rise over run. So if your slope is not a fraction, you need to make it into a fraction. 2 as a fraction would be 2 over 1. And that gives us a rise of 2 and a run of 1. Remember from a few slides ago, you always plot the y-intercept first on the y-axis, and then you use the slope in order to find and plot the other points. So let's start on the y-axis and plot the y-intercept of negative 4. So starting at the origin, I'm counting down 1, 2, 3, 4 units. So there's my y-intercept, and then starting from that point, I'm going to use my slope of 2 over 1 in order to plot the points. So that means I'm going to go up 2 and to the right 1. Starting from that point, up 1, 2, and to the right 1. 2 points determine a line, so in order to graph this equation, all I would have to do is connect those 2 points with a nice straight line. And there you have the line. Next, we are supposed to plot the line for negative 2x plus y equals 7. Notice in this equation, y is not by itself. so we need to get it by itself in order to graph the equation. But all we would have to do is add 2x to both sides in order to get that y by itself. Again, I like to have the x first. So it'd be y equals 2x plus 7. The 7 was positive, the 2 was positive, so we keep it as 2x plus 7. In this case, I would have the slope is 2, since it's the number in front of the x, and the y-intercept is 7, since it's the constant term. Remember, you always want slope as a fraction, so 2 as a fraction is over 1. We would plot the y-intercept first. Our y-intercept is 7, so that means I would count up 7 units. 1, 2, 3, 4, 5, 6, 7 units on the y-axis and put a point. And then starting from that point, we're going to use the slope rise over run in order to plot the other points. So it would be up 2 and over 1, just like last time. So starting from this point, we're going up 1, 2 units, and to the right 1. 2 points determine a line, so I'm just going to connect these 2 points with a nice straight line. So there's our 2 lines. Part C says, what do you notice about the lines? When I look at these 2 lines, I see that they run alongside each other, and both are going up 2 and over 1 forever and ever. They go up 2 over 1, up 2 over 1 forever and ever on both of them. So therefore, they would never intersect. Lines that don't intersect are called parallel lines. So what do I notice about these lines? They are parallel. And let's state the definition of what parallel lines are. Parallel lines are 2 lines that never intersect. So again, the 2 lines that we graphed were parallel. Let's look at their equations. One of them was y equals 2x minus 4, and the other one, once we got y by itself, was y equals 2x plus 7. Do you see how they both have a slope of 2? Again, that means that both of them are going to keep going up 2 and over 1 forever and ever. If they both continue at the same rate and they never change from that, they will never intersect. So therefore, lines that are parallel have the same slope. So again, anytime you see that 2 lines have the same slope, and again, those 2 equations would have to have y by itself. If they have the same slope, you automatically can assume that the lines are parallel. That's it for this section. Again, most of this section should have been a review from what you've learned in the past, but as always, if you have any questions, make sure you jot them down so we can cover them in class before you do your homework over this section.